Hi, I welcome all of you to our online lecture of B.Sc. II Analytical Chemistry. In last lecture, we have learned about the analysis of hematite ore, that is what estimation of main constituent in the hematite ore. It is what the first part, that is what the fusion and dissolution of the ore, what are the components present in hematite ore, and how one can what estimate the component present in, or which component we will have to be what we are going to estimate in the given hematite ore. In this lecture we are going to what learn about the second part of the that analysis of hematite ore, in which we are going to learn about the analysis of combined oxide, analysis of Fe2O3, analysis of Al2O3. So let's begin with this. So estimation of combined oxide, that is R2O3. R2O3 means what? Which are these oxides? That is what Fe2O3 as well as the Al2O3. So filtrate obtained after the estimation of the SiO2 by filtering, that is what the residue. In last lecture we have already learned about the estimation of SiO2 from the Fe2O3, that is what the hematite ore, by simply what dissolving ore, fusing ore, and after filtration, what incineration, drying, and ignition, whatever the residue is left, that residue is what measured and weighed. So whatever the quantity of that residue, and with the help of formula we can able to what determine the SiO2, estimate the amount of SiO2. But in next part we are going to what learn about the estimation of Fe2O3 and Al2O3, that is combined R2O3. So filtrate obtained after the estimation of SiO2 is used for the estimation of combined oxide. A filtrate free from SiO2 is used for the estimation of combined oxide. Heat the filtrate free from SiO2 and containing Fe+3 and Al+3 ions. To the hot solution, add sufficient amount, that is the amount of the ammonium hydroxide solution, with constant stirring. When Fe+3 and Al+3 get precipitated as respective hydroxide, that is what FeOH thrice and AlOH thrice, that is what after addition of ammonium hydroxide to the filtered solution by constant stirring will get the will get the precipitate of the respected hydroxide, that is combined hydroxide Fe2, that is FeOH thrice, and what AlOH thrice, that is what ferric hydroxide as it as the aluminum hydroxide. So what reaction occurs? Fe+3 plus 3 NH4OH, which gives FeOH thrice, that is precipitate of the iron hydroxide, plus 3 ammonium ion, as well as the Al+3 plus 3 NH4OH will get the AlOH thrice precipitate plus 3 ammonium ions. So the combined hydroxide precipitate is ROH thrice PPT is digested for 10 to 15 minutes, and by what gentle heating. What is digestion? We heat the given precipitate at constant temperature or elevated temperature to settle down the precipitate, or we will get the bigger size of the precipitate. So the ROH thrice precipitate is then filtered through a Wattman filter paper number 41. Wash the ROH thrice PPT with a small portion of very dilute ammonium nitrate solution for 2 to 3 times. Dry the filter paper with ROH thrice PPT on a hot cone. Transfer the filter paper with the ROH thrice PPT to pre-weighed platinum crucible. Incinerate or carbonize the filter paper initially on low flame or at low temperature in a muffle furnace without inflaming, After that, what ignite the ROH thrice PPT finally at what 700 degrees Celsius on a burner or muffle furnace till a constant weight is obtained. Cool in a desiccator and weigh the residue as R2O3 from the weight of the R2O3 residue and suitable conversion factor. The percentage of R2O3 in the iron ore is calculated. R2O3 percent, that is what the R2O3 present in the iron ore is equal to weight of R2O3 residue into conversion factor into 100 divided by weight of the iron ore. So this is what the formula for the estimating main constituent in the haematite. That RO is 3 combined oxide in the haematite ore. So how this haematite combined oxide in the haematite ore is determined? See, simple method is there. Firstly, what take the filtrate free from SiO2 and add to what this filtrate is boiled, and after this hot in the hot filtrate add ammonium hydroxide solution with the constant stirring. After adding this ammonium hydroxide, you will get the precipitate of the respected oxide hydroxide, that is what the iron hydroxide and aluminum hydroxide, that is what the Fe plus 3 plus 3 NH4OH, which after what reaction will get the iron oxide, the hydroxide, that is what FeOH thrice precipitate plus ammonium ions, and that is what with the aluminum will get the aluminum trihydroxide. Afterward, the precipitation completion of precipitate, this precipitate is digested on the low flame by heating 10 to 15 minutes, and after that precipitate is filtered through the Wattman filter paper number 41. Wash the ROH thrice PPT with a small portion of very dilute ammonium nitrate solution for 2-3 times, and dry the filter paper with ROH thrice PPT on the hot cone. Transfer the filter paper with ROH 3 PPT on the pre-weighed platinum crucible. Incinerate, carbonize, and the filter paper initially on low flame or at the low temperature in a muffle furnace without inflaming. After that, what ignite this precipitate finally at about 700 degrees Celsius on a burner or muffle furnace till a constant weight is obtained. Cool the precipitate in desiccator and weigh this precipitate. Weigh the residue as R2O3, that is what the combined oxide, from the weight of the R2O3 residue and suitable conversion factor. The percentage of R2O3 in iron ore is calculated. So with the help of formula, R2O3 percent in the, that is what the percent in the iron ore is equal to weight of R2O3 residue into conversion factor multiplied by 100 divided by weight of iron ore. In this way we can able to what determine the amount of iron ore, that is what the Fe2 represent in the given ore. Next, determination of moisture. So weigh accurately about 1 gram of the iron ore sample in a watch glass or in a platinum crucible. Place it in a oven maintained at 105 degrees Celsius till a constant weight is obtained. Cool in a desiccator and weigh immediately during heating at 105 degrees Celsius. The moisture water present in ore is expelled out. As a result, the ore experiences a weight loss which is equivalent to the amount of moisture present in the ore. So from the weight loss, that is amount of moisture, the percentage of moisture in the iron ore can be calculated. So it is what the moisture present, what is the moisture percent is equal to weight loss into 100 divided by weight of iron ore that is equal to amount of moisture into 100 divided by weight of iron ore. In this way we can able to what the estimate the amount of moisture present in the given ore. So how this estimation of moisture can be carried out with the help of this method, that is how this moisture is determined with the help of simply what the in the moisture determination we can what only what the evaporation of this moisture is takes place, expelling of this moisture takes place by heating at about what 105 degrees Celsius. So how see weigh accurately 1 gram of the iron ore sample in a wash glass or in a titanium crucible, place it in a oven, maintain at 105 degrees Celsius till a constant weight is obtained. Cool in a desiccator and weigh immediately during heating at 105 degrees Celsius. The moisture present in iron ore is expelled out. It is what get evaporated. As a result, the ore experiences a weight loss which is equivalent to the amount of moisture present in the ore. So from the weight loss, that is the amount of moisture, the percentage of the moisture in iron ore can be calculated simply with the formula, that is the moisture percent is equal to weight loss into 100 divided by weight of iron ore, or we can determine this by the help of another formula, that is amount of moisture into 100 divided by weight of iron ore. So in this way we can able to determine the moisture and combined oxide present in the iron ore, that is what haematite ore. So if you have any queries regarding this, please what comment your question in the answer box. I will try to I will try to give the answer to your question. So thank you. Thanks.